The offspring of the parent function, y equals x to the fourth power, is a subfamily of all quartic polynomials. This subfamily consists of quartics of the form y equals a times the difference x minus h to the fourth power plus k. The function y equals x to the fourth also belongs to another category of polynomials called power functions. In this category, you can generate families, as usual. Take note, key concept, power functions. A definition. A power function is a function of the form y equals a times x to the b power, where a and b are non-zero real numbers. Some examples. Y equals 0.5x to the sixth power, y equals 1/2 x squared, y equals negative 4 times x to the 2/3 power, and finally y equals x raised to the 0.25 power. If the exponent b in y equals ax to the b power is a positive integer, the function is also a monomial function. If y equals ax to the b power describes y as a power function of x, then y varies directly with, or is proportional to, the bth power of x. The constant a is the constant of proportionality. Power functions arise in many real-world contexts related to the concept of direct variation, which you studied in Chapter 2. Problem 4. Modeling with the power function. Wind-generated power. Wind farms are a source of renewable energy found around the world. The power P in kilowatts generated by a wind turbine varies directly as the cube of the wind speed V in meters per second. The picture shows the power output of one turbine at one wind speed. To the nearest kilowatt, how much power does this turbine generate in a 10 meters per second wind? Now note the image. The wind, 8 meters per second, generates electric power at 600 kilowatts. The formula for P as a power function of V is P equals A times V cubed. From the picture, P equals 600 when V equals 8, or 600 equals A times 8 cubed, simply substituting our output and input values into the power function P. Now we can solve for A. We'll use the values of P and V already substituted to find A. 600 equals 512 times A, so A is approximately equal to 1.1719. And now we'll solve for P. P is approximately equal to 1.1719 V cubed, and we'll substitute 10 for V, since our question asks to the nearest kilowatt, how much power does this turbine generate in a 10 meter per second wind, and we'll simplify. 1.1719 times 10 cubed is equal to 1171.9. So we can now state this turbine generates about 1172 kilowatts of power in a 10 meter per second wind. Your turn. Wind generated power. The power P in kilowatts is generated by a wind turbine. It varies directly as the cube of the wind speed V in meters per second. A wind turbine generates 210 kilowatts of power in a 12 mile per hour wind. How much power does this turbine generate in a 20 mile per hour wind?